Welcome to Academic Game Tutorials. In this video we will learn how a micrometer works, and the main parts and functions of different parts of a micrometer. We will learn about the least count of micrometer, and how to read an outside micrometer easily. So, let's get into the topic. The micrometer is a gauge, or device, used to measure the length, diameter, and thickness of a small object. In other words, a micrometer is a tool used for the precise measurement of very small objects. It can measure the depth, length and thickness of whatever object fits between its anvil and spindle. The micrometer works based on the principle of working of nut and bolt assembly. The least count of a micrometer is 0.01 mm, or 0.001 centimeter. This means that the minimum or lowest reading that can be measured by a micrometer is 0.01 mm, or 0.001 centimeter with accuracy. Now, let's list out the major parts of a micrometer. In a micrometer, there is a metallic frame, an axial graduated sleeve, a circumferential screwed spindle, a hardened steel anvil, a thimble, a ratchet stop screw, and a lock nut. These parts together form a micrometer. Now let's understand with proper diagram where these parts are located, and what are the functions of these parts. At first, there is the frame of a micrometer. The U-frame of micrometer is made of steel, cast steel, malleable cast iron or light alloy. There is a hardened steel anvil attached to the left-hand side of the frame. And on the right-hand side of the frame, there is the spindle. The anvil is used for holding and supporting the jobs for measurement. It does not move, and is fixed in its place. Whereas, the screwed spindle over here, it can move backward and forward. This spindle does the actual measuring, and it possesses threads of 0.5 mm pitch. These comparatively darker surfaces attached to both the anvil and the spindle are the hardened ends. They are hard and high wear-resistant surfaces. They are used to resist the micrometer from friction with the job surface, and protect the micrometer from wear. After that, there is a sleeve connected to the right-hand side of the frame. The sleeve is also sometimes called barrel. There is a lock nut attached here. This lock nut or locking lever is used for locking the micrometer for a desired amount of time after taking or setting the reading. After that, the main scale of the micrometer is engraved on this sleeve. Then, connected to the sleeve, there is a thimble. This thimble is a tubular or cylindrical cover attached with the spindle. It rotates and moves with the spindle when the spindle is adjusted for measurement. The circular scale of the micrometer is engraved on this beveled portion of the thimble. The linear scale looks like this, and the linear scale has readings on both up and downwards, and in between them there is a reference line. And, here we have the circular scale on the thimble. It has readings up to 50 mm, that is from 0 to 50 mm. In this main scale, or linear scale, or the sleeve scale, here each division is at a gap of 1 mm. So, the value of each division is 1 mm. So, here we have 0 mm, 1 mm, 2, 3, 4 mm, and so on. And this main scale is 25 mm long. There are half millimeter marks here provided above these markings. Here each division is half of one division of these main scale division. So, if one division of this linear scale or main scale is 1 mm, then one division in this scale will be half of it, which is 0.5 mm. So, here we have 0.5 mm, 1 mm, 1.5, 2, 2.5, 3, 3.5 mm, and so on. The circular scale has 50 divisions. One complete revolution of the circular scale moves the thimble 0.5 mm along the linear scale, and since the thimble is attached to the spindle, so, the distance between the anvil and spindle jaws is also changed 0.5 mm. Now, on the right end of thimble is provided with knurling. This knurling on the thimble provides grip when handling and rotating the thimble, so it does not slip from hand during measurement. So, this knurling provides us grip while holding the micrometer. And, at last we have the ratchet nut. This ratchet nut is used to move the spindle very softly when a job is to be adjusted between these two jaws. In other words, we use the thimble for frequent and hard movement of spindle towards the job, and after the spindle reaches near to the job, then this ratchet nut is used to move the spindle very softly, and thus hold the job softly during measurement and adjustment, to avoid wear and friction. Now, let's zoom into these main scale and circular scale and know about them a bit more, because they are very important in reading the micrometer. So, here we have the linear scale. There is a reference line between the upper and lower readings of this linear scale. So, here we have 0 mm, 1 mm, 2, 3, 4 mm, and so on. And above this we have 0.5 mm, 1 mm, 1.5, 2, 2.5, 3, 3.5 mm, and so on. So, between the upper and lower reading there is a gap of 0.50. That is, on this side there is 0.50, and on this side also there is 0.50 mm. As we discussed earlier, there are total 50 divisions in the circular scale. And, the least count of the main scale in 0.5 mm, because down we have 1 mm, and above we have 0.5 mm, so, the minimum measurement possible by the main scale is 0.5 mm. Now, let's find out the least count of the micrometer. When the thimble completes its one revolution, then the spindle moves 0.5 mm in the axial direction. In other words, when this thimble completes its one complete rotation of 360 degrees, then for one complete rotation of this thimble, this spindle advances only 0.5 mm. This is called the pitch. Now, the formula or least count is pitch divided by total number of divisions on the circular scale. We have already discussed that the total number of divisions on the circular scale or graduations on the thimble is equal to 50. And here, we also obtained the pitch, which is 0.5 mm. So, putting these values, we get the value of least count as 0.5 mm divided by 50, which gives 0.01 mm. So, least count of the micrometer is 0.01 mm. Now, let's learn how to take a reading on micrometer. The formula to find out the dimension to be measured is main scale reading plus thimble scale or circular scale reading multiplied by least count of micrometer. So, this is the formula to take any reading using the micrometer. So, let's see how to take a reading on micrometer. So, here is our micrometer. In between the anvil and the spindle of this micrometer we will place a job or an object that is to be measured, and we will grip the job or object using this spindle. Since this is an outside micrometer, we only take outside surface reading of the objects using this micrometer. When we rotate this thimble in the clockwise direction, this spindle moves forward towards the anvil. Similarly, when we rotate this thimble in the anti-clockwise direction, this spindle moves backwards away from the anvil. So, we have placed an object and adjusted in between the two jaws by rotating the thimble, and when there is very little space between the spindle and the object, then it gripped properly by softly moving the spindle by rotating this ratchet nut. When the job is properly adjusted between the anvil and spindle, then this locking lever is used to lock the spindle in its place. Now this object or job can be taken out easily, and due to this lock nut the measurement taken will not deviate. Now we can take the reading. For that, let's zoom into this scale. Then we can see this view. Now we will note this reading. We already know the formula for taking the micrometer reading is main scale reading plus thimble scale or circular scale reading multiplied by least count of micrometer. First main scale reading. Here we have 5 mm, then 10 mm. These lines are the main scale reading, so, our main scale reading here is 10 mm. But when we were rotating this thimble, here we can see one more line on the linear scale that is uncovered. And we have already discussed that the distance between this line and this line is 0.50 mm. So, the reading of this one more division is 0.50. So, our final main scale reading is 10 plus 0.50, which is 10.5 mm. Now, let's note the thimble reading or circular scale reading. Here, we can see the reference line on the main scale, and the line of circular scale that coincide with this reference line is the circular scale reading. We can see here that, 15 on this circular scale coincides perfectly with the reference line of main scale. So, circular scale reading is 15 millimeters. Now, putting these values in the formula, main scale reading is 10.5 millimeters, circular scale reading is 15 millimeters. We already learnt that least count of the micrometer is 0.01 millimeter. So, we get 10.5 plus 0.15. So, the reading obtained is 10.65 millimeters. Thus we can obtain an accurate reading using a micrometer easily. Thank you for watching this video. If this video was helpful, subscribe to my channel Academic Gain Tutorials for more updated videos.